Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound shown is triphenylmethane, pH 3CH, a central methane carbon, CH, bonded to 3 phenyl rings. Moving on to the next step. H plus and UlCl3 are strong Lewis-Bronsted acid conditions capable of generating carbocations and facilitating electrophilic aromatic substitution, Friedel-Crafts type cyclization. Moving on to the next step. Mechanistic concept, intramolecular Friedel-Crafts alkylation under acidic conditions, H plus UlCl3, the central CH bond can be activated, or a hydride shift protonation gives a triphenylmethyl carbocation, pH 3C+. Alternatively, the reagents promote an intramolecular electrophilic cyclization where one of the ortho positions of one phenyl ring attacks an adjacent phenyl ring's ortho carbon. And for the final step. In triphenylmethane, 2 of the 3 phenyl rings are in close proximity. Under acidic conditions, an intramolecular electrophilic attack occurs. The carbocation, or electrophilic carbon, at the methane position facilitates ring closure between 2 of the ortho-positioned phenyl rings. Specifically, one phenyl ring's ortho carbon forms a new C-to-C bond with the ortho carbon of an adjacent phenyl ring, creating a 5-membered ring fused between 2 benzene rings. This is the fluorene skeleton. The cyclization produces fluorene, dibenzo, A, D7, annuline's smaller analog, actually dibenzofuran analog without oxygen. Fluorene is 2 benzene rings fused via a cyclopentane ring, with the 3rd phenyl group remaining as a substituent at C9, the sp3 carbon of the 5-membered ring. This gives 9-phenylfluorene. The driving force is the formation of the aromatic stabilized bicyclic fluorene system. The intramolecular Friedel-Crafts reaction is favored because it creates a stable 5-membered ring fused to 2 benzene rings, and the reaction is intramolecular, high effective molarity. The remaining phenyl group at C9 cannot further cyclase under these conditions without significant strain. Therefore, the correct answer is 9-phenylfluorene, fluorine with phenyl substituent at C9 as drawn P.585. The correct answer is shown on screen.